All right, so hi everyone. I am Nenad Vitorovic. I'm a developer relations in Tenderly, and today I will be talking about the ways we can prevent transaction failures, the sources of transaction failures, and improve the Dapp user experience along the way. So a quick note before we start, we will have this demo is actually being recorded, so you'll be able to watch it offline if for some reason you have to hop off from the live session. And let's go into the agenda, what we'll cover today. So the problem with the failed transactions, we'll first look into what the problem is, where it surfaces, and in the Web3 space, DeFi is a pretty big area. So we'll talk about how it affects the users and in the end, how it can have implications on adoption of Web3 solutions. The second part, we'll talk about how to increase confidence by building better user experiences. So we'll talk about approaches that we could use in general, but also technologies that could help us. And of course, we'll see some real world examples where people are using some of these solutions to improve the user experience. Of course, since this is a live demo, we will have a live demo. That should be the biggest portion. And in the end, we'll do a Q&A session. So during the presentation, during the demo, feel free to ask any questions. We'll come back to all of those, or at least as much as possible by the end. We'll try to not go too much with time, maybe 30 or 45 minutes will be the total duration of this demo. All right, so before we actually get started, let me just take a quick look in what Tenderly is. So it's an all-in-one development platform, and this means that we're providing tools that can help you during the development of smart contracts, during the development of user interfaces as well. And this is the area of tools we'll be focusing on today. There's also an observability stack that helps you observe how your app is doing in production and what's going on in your project. And there's the infrastructure 3.0, which actually gives you direct access to the blockchain and allows you to make some sort of automations around your processes around your Dapp. And finally, there's the Web3 gateway, which is your entry point or your gateway to using the blockchain from your dApps. And now let's go into the actual problem. So what we're seeing here on this window is a MetaMask pop-up that popped up when I was trying to do a swap on Uniswap. And it says here, we cannot verify this contract. Make sure you trust this address. So MetaMask is giving a due notification. We're not sure what's going to happen. So you, as a user, you have to make sure that you trust this address. And the question is, how do users become sure it's safe to trust an address? And is there something that we can do about it when building dApps? So the user can either trust the contract or verify that the actions and effects of calling that contract are desirable in their view, and that behavior of the smart contract is what the user actually expects. And this is generally the problem we're facing. So let's see what is the impact of failed transactions. So transaction fails either, because it fails execution, so you have to spend money on paying the gas for that, or a transaction may fail because it's not actually failing, it has undesired effects for you. So the thing that we have here, we can look at it from three different angles. First of all, there's uncertainty and lack of predictability of the end results of transaction execution. So we know that blockchain is inherently transparent, but we also have those moments before we send a transaction out. And that is an issue that can be translated into it's a lack of visibility what transaction will do. So the fallback for the user would be, I hope I did everything well and entered all the inputs properly, but I don't have the visibility to be sure that I can trust that this transaction will roll out as I'd hoped to. And this leads to loss of money, well, due to unintentional mistakes. So the not knowing what will happen and getting undesired effects is something that's pretty much anxiety inducing for the end users. And we were all in this situation. So I personally have to check and recheck and, oh, okay, am I missing something? Is this swap okay? Should I try this when I'm less tired? But I have to do it now. It's critical to do it now. And this leads to exhaustion. So having an exhausting user experience, I guess it's not a good user experience at all. And all of these failures actually cost money and user satisfaction with the Dapp. So in the end, there's this finger-crossed approach that we have to rely on that software will behave as it's intended to, which, as we all know, especially developers, is not the reality. Bugs occur, bugs pop up, stuff doesn't work occasionally. So how can we be smarter about it? Let's just, before we try to answer how can we be smart about it, go just reflect on one additional thing, and that's that's actually the question: how users who are newcomers into Web3, so they're not pros, deal with this. This kind of friction and this kind of anxiety actually can result in pushing them away because it increases confusion, increases anxiety, and in the end, it prevents adoption of Web3 solutions. So let's talk about how we can approach and maybe solve this problem. So the main question is how to increase confidence through better UI. And the things that we can work on is actually enabling users to preview the transaction outcomes. This means that we work on the visibility problem. We work so that we can give insightful data to the users, data that's valuable, so they can make informed decisions about their actions before they actually take any action. Now, as a consequence, the meaningful data informing user decisions actually can eliminate the places of, let's say, slippage where something can go wrong, users can have unpleasant experiences, and users can actually lose money. So in the end, we're creating a forgiving environment, a forgiving user experience that is forgiving for trial and error. We can actually improve the experience for the newcomers and the beginners. And in essence, it's about bringing the don't trust verify to our Dapp users so they can actually use our Dapps with confidence. So now that we understand how we address the problem of lack of visibility and how we can make it more forgiving for errors, let's see how we can actually implement this solution. And the key thing here is enabling users to preview transaction outcomes. And spoiler alert, it's Web3 Gateway simulations. So Web3 Gateway simulations actually allows you to use Tenderly's Web3 Gateway, but use it not only for blockchain access, but also to simulate transactions. And before we actually see what's in the box, let's just stop for a minute and think about what simulations are. So simulations are doing the thing, but not in the real costly environment. It's doing the thing in a cheaper environment, such that undesired effects aren't really harmful to anybody. So you can think of it as, instead of going to space and seeing how you would react to zero gravity or high acceleration, you can also go to a simulation chamber or a simulation plane and see how your body reacts to zero gravity. And this is exactly what simulations do to transactions. So to come back to what Web3 Gateway is, inside we have, well, the regular standardly defined JSON RPC interface for blockchain access. And this is something you use when you do ETH send transaction or ETH call. So it goes into that part and of course uses blockchain to read and write data, of course, when you do send transaction. But you can also use the other part, and that's the custom tenderly_simulate transaction. This is this is the first and one of many custom JSON RPC endpoints in the Tenderly namespace that allows you to do custom things. So when you want to simulate a transaction to preview its outcome, you would use this. And of course, this simulation part would read the data from the blockchain and show you practically a calculation, which gives you the insight, the preview of the transaction without it actually being written on the blockchain. So this is the technological aspect of it and what we could use there. So now that we talked about it a little, even before the demo for the engineers in the crowd, let me go here and let me show you. This is the Tenderly dashboard. And right now, let me just close off this one. And this is the Web3 gateway view. In here, we have, of course, the links to the JSON RPC interface for the gateway for the node as a service for this project. And we have an RPC request builder. So here you have a nice UI you can use to actually build out a transaction you would like to send or ETH call or simulate a transaction. And I pre-filled this one with one transaction that is very much alike to the one that will appear in the live demo. So we have the regular transaction fields, the from, the to, the gas price, value, data, all sorts of things. And when I hit send request, well, this is the actual JSON RPC URL, actually JSON RPC request you can use to ask Tenderly to, well, simulate the transaction. And down here, we can see the outcome of this simulation. So this is a little crammed in here, so I'm gonna go here. This is the exact output of the thing we just saw, and just to see what's in there. So in there we have, well, the result status succeeded, the block number, we have the logs, and this practically is showing you all the decoded events emitted by this smart contract as the transaction executed. So the event name was transfer, these are the inputs. So the first input of the event is called from, it's an address, and this is the value. The second one is to, also an address, this is a value, and so on and so on. We can see all the events are actually decoded, but if we keep scrolling down, we can also see the trace. Now, this section actually shows you which smart contracts would be called via internal transactions during the execution of this one that we just sent using the UI. So here we can see the contracts that's being called, the decoded input for the function that's being called. So these are practically the arguments to the function. This is the actual method or the function of that smart contract. And this is the decoded output. So showing you what that function returned to the caller. And of course, we have all of these for all the involved contracts along the way. So you can actually analyze in your Dapp, if that makes sense, which contracts interacted and which information they exchanged as the transaction was executing. So this was a little detour to the technical side, and we'll come back to this again in the demo. This was just to show how you can actually use it. And let me come back into the presentation here. All right. So, as I said, we will show a use case actually, and this is a recording of the Safe Dapp. So Safe, it's a multi-sig wallet, let's say, provider, you can use to instantiate a multi-sig wallet on blockchain and submit transactions into that multi-sig. So you can the transactions are in there, they're waiting until enough owners actually agree it's safe to execute them. And let's see how the UI works. So right here we can see I added 2 transactions with some value and some data, and I might be wondering, is it good, is it not good, should I send this into the multisig or not? So even here I might avoid wondering and fingers crossed and do a simulation. So the simulate button actually relied on Tenderly simulation, and it shows that one or both of these transactions failed, so you can actually see the simulation report. And in this way, people actually can avoid doing things that are costly and simply well, be more productive and efficient with their use of Web3. So let me just switch to the next slide. Yeah, this is a quote from the co-founder of Safe, saying that normally every second or minute, somebody is simulating transactions. So it's that important to be very well informed about what you're about to do. All right. And now we're coming to the demo mark. So the demo will be to show how we can add simulations into an existing Dapp so the users can have more awareness of what's going to happen when I click that big button. And to do that, let me go to the browser. So it's a Dapp, here it is. And what we've actually done is, let me just refresh this so we have a clean screen. So what we've actually done is we've taken the Uniswap code, which is open source, and we enriched the UI by adding simulation of the swap before actually confirming that we want to swap. So I'll just enter some amount of ETH, and I'll go to swap it for DAI, and this is just Uniswap fetching prices. This is the amount that would be there. And when I click swap, I have this confirm swap. Modal. And all of this that's not in this purple color that doesn't really fit the UI is actually Uniswap. So showing you how much ETH you put in, how much DAI you would get, and this will be the expected amount of DAI that you get. Also, the minimum after slippage and so on. So all of that information. So, and in the very bottom, one of the indicators for the user, if this is right for them, is just being aware what is their balance of ETH before the transaction and what would the balance of ETH after the transaction be. And this is the one. So if you really want to calculate, when we subtract 0.01 from this first number, we will get this one. Okay, fairly easy. And the other thing is showing how the amount of DAI for this user, and before the swap it's 0, and after the swap it goes to 12.700 something. All right, so this looks cool, and it's also very cool that this thing appeared when I opened the window. So when the confirmation dialog appeared. So in here, we could almost instantly, in a very, very fast way, inform the user about the outcome of their actions. And of course, it's up to them to decide if those outcomes are something that they're willing to accept. All right, so this is what happens in the UI. And let's go into the Visual Studio Code. So here, I'll go back into this confirm swap modal. And I added one little component called simulation, very smart, unexpected name. And I will just show you the code that gets the balances before and after, and also gets the outcome of the simulation. So here, getting the balances before anything happens, it's pretty pretty straightforward. So we're calling the ETH get balance for this current account I'm in on the latest block. So that's all I have in my wallet. And of course, ETH call to the DAI token. Now, you see, this is just hard-coded for DAI, but it could be easily changed up. So it could actually communicate to any ERC20 token. And these two calls are sent. And of course, we wait for both of them to come in. And these are just all balances, simple as that. Now, another thing that we're doing here, all right, this is me getting the provider. And of course, this uses Tenderly's gateway as the provider. And we're sending the Tenderly simulate transaction. And in here, we're sending absolutely the same data that Uniswap would send to ETH send transaction. So the account, the one who's actually initiating it, the address, the call data, and this address over here is the Uniswap router's address. The call data is actually containing the request itself. So this has encoded in it the amount, the input amounts, and it's got encoded the tokens that should be swapped. And the value is, of course, the value. So simple as that. It's the same transaction that you would send to the network, you send to Tenderly simulate, and then you have the output. Well, the result of that is simulation response. So with simulation response, this is up to you, depending on the contracts you're working with, how to actually parse the data, what to extract, what to show to the users, and so on and so on. So here, in this case, what was enough was actually just to take the logs and actually filter out only for transfer events. That's one thing. And the second thing is also take all the events and filter out only the one and only swap event that's happening here. And of course, since this is React, I had to put these into the component state. And after the component state finished, got updated, I have also this UI-ish thing, the simulation details, that actually displays all this data. So what it does, it's taking the all balances. Let me go into this one. All right, a little bit hacky, but that's okay. It proves the point. So we're taking the all balances that are shown in ETH at 4 decimals, and we're also taking the amounts of, well, the first token and the 0 token, and adjusting those. So these are practically the deltas to the balances. These are original balances. So this calculation over here, new balances, is actually giving us the values that are happening after the swap is done. And I'm not going into the UI code. Yeah. So to recap, the only thing we did here is before actually sending the transaction, either automatically or before user confirming that they want to do the swap, we just sent a very same object to the Tenderly simulate transaction endpoint. And in this way, we got all the information we needed to come up with something sensible, even for a user who is not really tech savvy. So this would be enough for that kind of user something happened. This would be enough for that kind of user to actually figure out if this transaction is something they want to do or not. Let's go back. Yeah, much better. All right, so that concludes actually the live demo that has that was here to show us how we can improve the user experience and how we can reduce the anxiety by providing insight and visibility into the behaviors, actually potential behaviors of smart contracts by simulating the execution of transaction on those smart contracts. And now I can either confirm or decide not to, and for the demo, I'll decide not to. And the last bit is, again, very tech-oriented. So more often than not, in order to simulate a transaction, you would also sometimes like to set some particular states to the state variables of the contract. And this is absolutely possible with simulate transaction. So just to circle back, it receives 3 parameters. First of them is transaction. The second one is the block number. And the third one is a map of overrides. And this thing over here says that we want to take this contract and override the balance of that contract and set it to this particular value. So what it does is it instructs tenderly, all right, simulate this transaction over here, including this data, but pretend the balance is 1. So pretend that the state is whatever we specify here. And this is the way you can actually override state variables before making call. That pretty much concludes the demos. The demo, for technical information, there are docs you can consult. And now we'll switch to the Q&A.
All right. Thank you, everyone who asked a question. So I have a couple of questions posted. What's the rate limit?
So the rate limit for doing simulate transaction, I guess that's the question. So for all the plans, rate limits are actually sufficient so that you can do 2 simulations per second. So if you actually have a very intensive or demanding Dapp and you need bigger throughput or bigger rate limit, in that case, well, you can contact tenderly support and come with that kind of request.
All right. Please don't forget to add your questions to the Q&A chat bot so that Nanet has a chance to reply. We have a second question here. Can I get all the data simulations offer for historical transactions?
Can I get all the data?
Simulations offer for historical transactions.
All right. So all this data that's available in the simulations is not possible. It's not possible actually to get it directly for historical transactions. So we are working on extending the Tenderly namespace with such utilities. So specifically, the trace transaction is one of those that's upcoming, and it will provide this level of fidelity into the data. Until that comes along, you could actually simulate that historical transaction, simulate the execution in the same place, actually at the same time, or to be specific, in the same block it was originally executed, and that way you would get all this data.
So Nana, somebody asked to repeat what the rate limit is. Somebody from the audience said that they missed it. All right.
So the rate limit for all the plans is sufficient to so you can execute two simulations per second. That's the rate limit. I don't know the exact numbers now, but 2 simulations per second are definitely possible.
Okay, awesome. The next question is, what is simulation speed?
So the time to actually do a simulation is on average below 200 milliseconds. This is, yeah.
And the next one, what's coming up?
What's coming up? So I mentioned extending the Tenderly RPC namespace with new endpoints such as trace transaction, but also state decoding to the simulations. So extending on that area as well.
And another question, do you support proxy contracts?
No, it's in the works and will be rolled out soon.
All right, so it looks like it's all the time I have today. If we didn't get to your question, there is another question. When will the Web3 gateway be available on other chains? Sorry. Okay, I'm gonna ask our friend Nebojša Urašević to address this question because there are a lot of very specific technologies.
Sure. Thanks, Elena. So the gateway support for the other chains, specifically in this question, Arbitrum, Polygon, and Avalanche, will be probably coming in the upcoming year. There are still some technical difficulties due to the architecture that we have, and we are currently assessing supporting all of the chains, all of the EVM chains that we have in our platform at the moment to the gateway, and allowing more adoption and more usage on the gateways. Thank you.
Great. Thank you. Thank you, Nebojša. Thank you, Nenad. That's all the time I have today. Big thanks to all of you who sent the questions and attended the webinar. If you have any questions, please make sure to contact us or contact me directly at elena@tenderly.co or visit our website at tenderly.co. Or if you have very specific questions about Tenderly or simulations or how to get started, please contact our friendly support team at support@tenderly.co. Also, please follow us on Twitter and Discord to stay up to date with the latest. And thanks again for attending and enjoy the rest of your day. See you next time and happy holidays from all of us at Tenderly.